So I'm going to finish up the examples that we didn't finish today in class. So like the rules that we were saying on the first side of the notes, we want to make sure that the absolute value bars are always by themselves on one side. So in example number 4, we're going to have to get rid of that 7. So I'm going to go ahead and subtract 7 from both sides. That's going to give me an absolute value of 1/2 x minus 3 is going to be equal to -9. And then at this point, I can go ahead and separate my equations like I did in the other example. So my first equation is going to be 1/2 x minus 3 is equal to -9. Again, exactly the same as our equation up there, just with the absolute value bars dropped. And over here, we're going to have a 1/2 x minus 3 is equal to a +9. So it's going to be the opposite of whatever the number is on the other side. So I'm going to go ahead and solve each one of these for x. So that's going to give me 1/2 x is equal to a -6. And then you have a couple of options at this point. You can divide each side by 1/2, or what I'm going to do is I'm going to multiply by the reciprocal of 1/2 on both sides. And the reciprocal of 1/2 is just 2/1. So over here, that's going to allow me to cancel out my 2's, so that's just going to leave me with an x. And over here, -6 times 2 just gives me a -12. And then I can go ahead and solve the other equation just the same way. So add 3 to both sides. It's going to give me a 1/2 x is equal to a +12. And then again, you can divide by 1/2. I'm going to multiply by the reciprocal here. So multiply by 2/1. Again, my 2's end up canceling out over here. So I am left with an x is equal to 24. So we said that we're not done yet because remember we have to check our solutions to see if they work or not. So when I check, I'm going to check back into the original equation that I was given. So I'll check my x is equal to -12 first. So 1/2 times -12 minus 3 and then plus 7 is equal to -2. And again, we're not solving anything over here. We're just literally simplifying all the way down. So that's going to give me a -6 minus 3 in the absolute value bars plus 7 is equal to -2. That's going to give me the absolute value of -9 plus 7 is equal to -2. Absolute value of -9 is +9 plus 7 is equal to -2. Hopefully you can tell that over here when we simplify this to 16 is definitely not equal to -2. So that tells me that that x value of -12 is not going to be a solution. So let's check the x is equal to 24. So 1/2 times 24 minus 3 plus 7 equal to -2. So half of 24 is 12 minus 3 plus 7 equal to -2. That's going to give me a absolute value of 9 plus 7 equal to -2. You'll see that we're going to end up with kind of the same thing that we did in the last check. So 9 plus 7 gives me 16. Obviously, that is not equal to -2. So what happens is when neither solution works, we just say in general, this equation has no solution. And we're going to talk about why. So why is this one different than examples 1, 2, or 3? Well, if you notice up here, what the equation was equal to in the initial thing that we were given and when we got the absolute value bars by itself, both of these equations were equal to a negative number. So think back to the first example that we went over together in class. We said that the absolute value of -2 gave us a +2, and the absolute value of a +2 gives us a +2. Well, in any instance, there's never going to be a time where something inside of an absolute value bar gives us a negative number. So we could have actually told over here when we got the absolute value bars by themselves that this was equal to a negative, and there's no possible way that there's going to be any number that I can plug in over here to get a negative number over here. So we could have actually skipped all of this work down here to know that this was actually a no solution equation right away. And you guys can do that from now on. If you're noticing that once you get the absolute value bars by themselves and you're noticing a negative number is happening on that side, you can automatically say there's no solution. So we'll look at one more example. So this one's a little bit different because now I have a binomial over here on the right-hand side instead of just a number. So I'm identifying that my absolute value bars over here are by themselves. I don't have to do any movement. So I'm going to go ahead and split up my equations. So my equation over here is just going to be exactly the same thing as what we started with, except just losing the absolute value bars. So 3x plus 2 is going to be equal to 4x plus 5. But when I set up my equation over here, this is going to kind of be the same rule that we were using for the other ones. In the second equation, both signs of this binomial on this side of the equation have to change. So what that's going to look like is when I set up my equation, I'm still going to keep the 3x plus 2 exactly the way it is. But on the other side, when I put my equals to, just the same way that we took the opposite of 9 over here in this equation, we're going to take the opposite of 4x, which is going to be negative 4x, and we're going to take the opposite of positive 5. So it's going to be negative 5. So from here in your second equation, both of your signs need to be opposite. So from here, we can go ahead and solve for x. So in the first equation, I'll subtract 3x from both sides. That'll give me 2 is equal to x plus 5. So I can go ahead and subtract 5 from both sides. So that's going to give me an x value of negative 3. And I'll go ahead and solve this one as well. So I'll move the 4x to the other side. That'll give me a 7x plus 2 is equal to negative 5. Subtract 2. That leaves us 7x is equal to negative 7, and then I can go ahead and divide each side by 7. So that'll give me a possible x value of negative 1. But again, we're not done yet because we have to check to see if these are actually going to be solutions, because in the last example, we saw that there is a possibility for these not to work. So let's check the x is equal to negative 3. And when you go to check, again, remember you're using your original, so we're actually going to have to plug in on the left side and the right side. So absolute value of 3 times negative 3 plus 2 equal to 4 times negative 3 plus 5. That'll give me a negative 9 plus 2 on the absolute value bars. And then over here, that'll give me a negative 12 plus 5, which will leave me with a negative 7 on the inside of the absolute value bars. And over here, that actually gives me a negative 7. But just remember that you're not done yet. I know a lot of people like to stop at this point and say, oh, look, I have a negative 7. But remember that you do have to take the absolute value of that. So this is going to give us a positive 7 is equal to a negative 7. So in this case, this actually does not end up being a solution. So negative 3 actually doesn't work here. So let's check the negative 1. So absolute value, 3 times negative 1 plus 2. Over here on the right side, 4 times negative 1 plus 5. That's going to give me a negative 3 plus 2 on the inside of my absolute value bars. Negative 4 plus 5 over here. That's going to give me the absolute value of negative 1 is going to be equal to a positive 1. So again, you do need to take the absolute value of this before you're done. So that tells us that 1 is equal to 1. Guess what? That's a true statement. So what I'm going to do is I'm going to go back up here and I'm going to say, okay, I know that negative 1 is going to be a solution because it works. And I'm also going to write a comment over here that says that x is equal to negative 3 is actually not a solution. So I'm differentiating between what's a solution here and what's not a solution. So it's your turn to try some practice now. Let me know if you have any questions as you're working.